You have three switches in a room. One of them is for a bulb in next room. You cannot see whether the bulb is on or off until you enter the room. What is the minimum number of times you need to go into the room to determine which switch corresponds to the bulb in next room? So to simplify, there are three switches in a room where one of them is assigned for a bulb in the next room. You can't see whether the bulb is on or off until you leave the room. Find the minimum number of times you have to go into the room to identify which switch corresponds to the bulb in the other room. Let me explain the solution now. The answer to this puzzle is 1. You need to enter the room only once to determine which switch corresponds to the bulb. Let me explain the solution in detail. First, switch on the first switch and wait for some time, say 5 minutes. Now switch off the first switch and switch on the second switch. Now enter the room. If you find the light bulb glowing, then the second switch corresponds to the bulb. If the light bulb does not glow, just touch the light bulb to check if it emits heat. If the bulb exhibits at least some heat, then the first switch corresponds to that bulb. If the bulb does not exhibit heat, then the third switch corresponds to the bulb. Let me repeat the solution now. You need to enter the room only once. First, you switch on the first switch and wait for some times, say some 5 to 10 minutes. Now switch off the first switch and switch on the second switch. Enter the room. If you find the light bulb glowing, then the second switch corresponds to the bulb. If the light bulb does not glow, just touch the light bulb to check if it emits heat. If the bulb exhibits at least some heat, then the first switch corresponds to that bulb. If the bulb does not exhibit heat, then the third switch corresponds to the bulb. So by following these simple steps, you can identify which switch belongs to the bulb easily. Six tigers can catch just 6 rabbits in 6 minutes. So how many tigers will be needed to catch 60 rabbits in 60 minutes? The immediate answer will be 60, but however, that is not the right answer. With mathematics, there is always something under the carpet. You have to look close. Feel free to pause the video and give a try before checking the solution. Once done, continue watching the video for the right answer. Let me explain the solution now. There is a general formula approach and logical approach to solve this problem. I will explain both. Let me explain the formula approach first. If M1 number of people can do W1 work in D1 days working T1 hours each day, and M2 number of people can do W2 work in D2 days working T2 hours each day, then the relation between them will be M1 times D1 times T1 over W1 equals M2 times D2 times T2 over W2. So here in this problem, the given information is 6 tigers can catch just 6 rabbits in 6 minutes. So what we are supposed to find is the number of tigers which is required to catch 60 rabbits in 60 minutes. So for this problem, there are only 3 variables. Hence formula can be written as M1 D1 over W1 equals M2 D2 over W2. Where M is number of workers, D is number of days, hours, minutes, seconds, and W is piece of work. Here catching rabbit is considered as work done by tiger. So M1 equals 6, D1 equals 6 and W1 equals 6. M2 is what we are supposed to find. D2 is equal to 60 and W2 equals 60. Now, after substituting all the values, the equation becomes 6 times 6 over 6 equals M2 times 60 over 60. After solving this, we get M2 equals 6. Therefore, 6 tiger will be needed to catch 60 rabbits in 60 minutes, and this is the formula based approach. Sometimes the formula is not required in order to solve this problem. So let me explain the other ways to solve this puzzle without using formula. So one way is, so the given information, as we already know, that is 6 tigers can catch 6 rabbits in 6 minutes. According to this statement, 1 tiger can catch 1 rabbit in 6 minutes. In 60 minutes, each tiger can catch 10 rabbits. So each tiger can catch 10 rabbits in 60 minutes, but there are 6 tigers, hence 6 tigers can catch 60 rabbits in 60 minutes. So this is the straightforward approach. There is an alternative method. So consider again the given information, which is 6 tigers can catch just 6 rabbits in 6 minutes. So it is said in the question that 6 tigers can catch 6 rabbits in 6 minutes. If you multiply it by 10, the same tigers can catch 60 rabbits in 60 minutes. So the answer will be 6. So these are the logical ways of looking into the problem, and this is good way to solve the problem if the statements given are easy and variables are minimal. But if the given problem is difficult, then it is better to go with formula approach in order to avoid any kind of mistakes. Suppose we have 3 glasses and 10 coins. The problem is to place odd number of coins in each glass. That is, each glass should contain coins and the number of coins in each glass must be odd and total coins which will be used must be equal to 10. Let me repeat the puzzle. Suppose we have 3 glasses and 10 coins. The problem is to place odd number of coins in each glass. That is, each glass should contain coins and the number of coins in each glass must be odd and total coins which will be used must be equal to 10. Feel free to pause the video and try yourself before checking the solution. If you are new to the channel, do subscribe to the channel and do not forget to comment your answer in the comment section. This is one of the fantastic puzzle asked in the job interviews. Let's check the solution now. See, it is not possible to use all 10 coins with each glass having odd number of coins. This is because if you add odd number of coins odd number of times, then the result is always odd but not even. But here there are 10 coins which is even. That is the challenge here. There are even number of coins but number of glasses are odd. Therefore, we must think out of the box. Let's solve now logically. So in the first step, in the first glass, place 5 coins which is odd. After that, in the second step, in second glass, place 2 coins, and in the third step, in third glass, place 3 coins which is odd. Here the first glass contains 5 coins which is odd, second glass contains 2 coins which is even, and the third glass contains 3 coins which is odd. Now is the important step. After third step, glass 1 has 5 coins, glass 2 has 2 coins and glass 3 has 3 coins. Now place the entire third glass inside second glass. By doing this, we are making sure that the second glass has 5 coins. Hence, indirectly, now second glass contains 5 coins which is odd in nature. So this I will consider as one of the fantastic puzzle because it requires out of the box thinking. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month so that at the end of its second month, a female can produce another pair of rabbits. Suppose that rabbits never die and that the female always produces one new pair, one male and one female, every month from the second month on. How many pairs will there be in 1 year? This is an excellent puzzle. Don't come to conclusion immediately. This requires a proper analysis to find the correct solution. Feel free to pause the video and give a try before checking the solution. Let's everyone know your answer in the comment section. Let me explain the solution now. To begin with, initially there are newly born pair of rabbits. Also, we know that newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of its second month, a female can produce another pair of rabbits. So at the end of the first month, they mate, but there will be only one pair. It is because rabbits are able to mate at the age of 1 month, so that at the end of its second month only, a female can produce another pair of rabbits. At the end of the second month, the female produces a new pair, so now there are two pairs of rabbits in the field. So at the end of the second month, there are two pairs. At the end of the third month, the original female produces a second pair, making three pairs in all in the field. This is because it is given in the question that rabbits never die and that the female always produces one new pair, that is, one male, one female, every month from the second month on. So at the end of the third month, there are three pairs. Now, at the end of the fourth month, the original female has produced yet another new pair. The female born 2 months ago produces her first pair also, making five pairs. So at the end of fourth month, there are five pairs. Now at the end of fifth month, the original female has produced yet another new pair. The female born 3 months ago produces her second pair. The female born 2 months ago produces her first pair, making eight pairs. So at the end of the fifth month, there are eight pairs. This continues, but the problem is it is difficult to keep the track and solve this problem like this. Let's check, is there a pattern to generalize the solution? So pattern is, initially there is one pair, at the end of first month still there is one pair, at the end of second month there are two pairs, at the end of third month there are three pairs, after 4 months there are five pairs, after fifth month there are eight pairs, and this continues. And this is the sequence of numbers which famously called the Fibonacci sequence. In the Fibonacci sequence, the next number is found by adding up the two numbers before it. Here is a first 13 Fibonacci numbers. As we can clearly see that here the first two numbers are 0 and 1. The next number is found by adding up the two numbers. Here the first two numbers are 0 and 1. Next number 1 is found by adding the two numbers before that. That is 0 plus 1 equals 1. The next number 2 is found by adding the two numbers before it. That is 1 plus 1 equals 2. The next number 3 is found by adding the two numbers before it. That is 1 plus 2 equals 3. And the next number 5 is found by adding the two numbers before it. That is 2 plus 3 equals 5. And this continues. This puzzle follows the Fibonacci sequence starting with 1. Here is the sequence which represents the number of pairs present after 1 year. So as we can clearly see that there are 233 pairs of rabbits present after 1 year with this logic. Thus, answer to this puzzle is 233 pairs of rabbits. There are 233 pairs which will be there in 1 year. For your information, Fibonacci sequence was first discovered by Italian mathematician Fibonacci, also known as Leonardo Bonacci. The original problem that Fibonacci investigated was in the year 1201, and it was about how fast rabbits could breed in ideal circumstances. You are given 8 identical looking balls. One of them is heavier than the rest of the 7. All the others weigh exactly the same. You are provided with a simple mechanical balance and you are restricted to only 2 uses. Can you find the heavier ball? Let me repeat the puzzle. You are given 8 identical looking balls. One of them is heavier than the rest of the 7. All the others weigh exactly the same. You are provided with a simple mechanical balance and you are restricted to only two uses. Can you find the heavier ball by using only two uses of the mechanical balance? Feel free to pause the video and try yourself before checking the solution. Let's everyone know your answer in the comment section. Let me explain the solution now. For convenience sake, let's name the balls 1 to 8. First, we weigh 1, 2, 3 on the left and 4, 5, 6 on the right. This is the first measurement. There are three scenarios which can arise from this. Let's consider the scenario 1. If the left side is heavier, then we know that one of 1, 2 or 3 is the heavier ball. Now in the second measurement, weigh 1 on the left and 2 on the right. We will know if 1 or 2 is heavier. If they balance out, then 3 is the heavier one. Thus, heavier ball is identified by exactly two measurements in this scenario. Let's consider the scenario 2. If the right side is heavier, then we know that either 4, 5 or 6 is the heavier ball. Now in the second measurement, weigh 4 on the left and 5 on the right. By doing this, we will know if 4 or 5 is heavier. If they balance out, then 6 is the heavier one. Thus, heavier ball is identified by exactly two measurements in the scenario 2. Let's consider the final scenario, that is scenario 3. If 1, 2, 3 and 4, 5, 6 balance out, then we know either 7 or 8 is the heavier one. Weigh both of them to find out which one is heavier. Again here, heavier ball is identified by exactly two measurements. Let me summarize. The first step is determining which set of 3 balls contains the heavier one. So choose balls 1, 2, 3 and balls 4, 5, 6 and weigh them. If one set is heavier, save those 3 balls. Pick 2 balls and place for measurement. By doing this, we will know which one is heavier. If they balance out, then other is the heavier one. If neither side is heavier in the first step, proceed with balls 7 and 8. In the final weighing, weigh both of them to find out which one is heavier. By following these simple steps, we can find which ball is heavier in just 2 measurements. The scenario comprises of a wobbly bridge and 4 people. It is the night time and the people have only one torch. Without torch, one may risk his life in crossing the bridge. Also, we have a condition. The bridge is not quite strong and can hold only 2 persons together at once. The 4 people take different time to cross the bridge. The timings are 1 minute, 2 minutes, 7 minutes and 10 minutes. Since the torch is a necessity and the bridge can't hold more than 2 persons at a time, 2 persons must travel at a time, out of which one must return with a torch so they don't risk their life crossing in the dark. What is the shortest time that will be required for all of them to cross the bridge? Let me simplify the puzzle. 4 people need to cross a bridge at night. Unfortunately, they have only one torch and the bridge is too dangerous to cross without one. The bridge is only strong enough to support 2 people at a time. Not all people take the same time to cross the bridge. Times for each person is 1 minute, 2 minutes, 7 minutes and 10 minutes. For example, if the 2 people with the speed 7 and 10 minutes were to cross together, it would take 10 minutes, leaving 17 minutes for one of them to return and get the rest moving. Can you find what is the shortest time needed for all 4 of them to cross the bridge? This is a very famous interview puzzle asked in several job interviews. Feel free to pause the video and give a try before checking the solution. Were you thinking of using the fastest person who takes 1 minute to travel to and fro till everyone has reached the other end? Yes, that can be done, but it will take 10 plus 1 plus 7 plus 1 plus 2 equals 21 minutes in total. If you pay attention towards finding a way to merge the one taking 7 minutes and the one taking 10 minutes, we will have to acknowledge the fact that one of them will also have to return back, which will take much more time than 21 minutes. What if we use the person taking 2 minutes to escort the one taking 1 minute across? Let's come to the conclusion. So in first step, 192 crosses the bridge and 2 returns with the torch. Here time taken is 2 plus 2 equals 4. In the second step, 7 and 10 crosses the bridge and one who was already in the other side come back. Here time taken is 10 plus 1 equals 11. In the final step, 192 crosses the bridge. Here time taken is 2 minutes. In such a manner, the total time taken will be 2 plus 2 plus 10 plus 1 plus 2 equals 17 minutes. Alternatively, the same time can be achieved like this. 1 and 2 go first, then 1 comes back, then 7 and 10 goes and 2 comes back, then 1 and 2 go again. It makes a total of 17 minutes. This is one of the most popular puzzles asked in several job interviews. You are a king of an empire. You have a servant working in your palace. He works all the 7 days and you only pay him in the form of gold bar. You must pay the worker for his work every day at the end of the day. If you are only able to make 2 breaks in the gold bar, how will you pay the servant if the servant works for the equal time every day and thus equal amount must be paid at the end of the day? This is one of the interesting puzzles asked in several job interviews. Feel free to pause the video and give it a try before checking the solution. If you are visiting this channel for the first time, do consider subscribing. If you are thinking of how to cut in such a way that you are able to make 7 equal pieces, you are thinking in the wrong direction. You should give more stress on how to make the transactions with the worker. So the trick is not to try and how to cut in such a way to make 7 equal pieces, but rather to make transactions with the worker. Make 2 cuts on the gold bar such that you have the following sizes of bars. Bar A should be 1/7 of the bar. Bar B should be 2/7 of the bar. Bar C should be 4/7 of the bar. Let's check whether it is going to work. When the day 1 ends, give bar A to the worker. Here you remain with bar B and bar C. Worker possesses bar A. When the day 2 ends, give bar B to the worker and take the bar A back. Here you remain with bar A and bar C. Worker possesses bar B. When the day 3 ends, give bar A to the worker. You remain with bar C. Worker possesses bar A and bar B. When the day 4 ends, give bar C to the worker and take back bar A and bar B. Here you remain with bar A and bar B. Worker possesses bar C. When the day 5 ends, give bar A to the worker. You remain with bar B. Worker possesses bar A and bar C. When the day 6 ends, give bar B to the worker and take back bar A. Here you remain with bar A. Worker possesses bar B and bar C. When the day 7 ends, give bar A to the worker. Here you remain with no bar. Worker possesses bar A, bar B and bar C. Thus by the end of 7 days, you have taken care of everything. This is a clever logical interview puzzle. 99% of the people fails to answer this. If you are lucky, you can get the same question and you can answer in less than a minute. That's all for this video. Let me know if you have any questions. I will try to address as soon as possible. Thanks for watching. Let's meet in the next video with one more interesting puzzle. Thank you.